Welcome to SIPROTEC 5. A new generation of innovative and intelligent field control devices is ready to fulfill your requirements. In the development of SIPROTEC 5, one thing in particular was vital: you. That's why the devices of the SIPROTEC 5 family are optimized to the challenges in your daily life. Together with the powerful DIGSI 5 engineering tool, SIPROTEC 5 field devices are very well suited for all protection, control, monitoring, and measurement tasks in electric energy systems today and in the future. For you, that means long-term investment protection while having a high degree of security and availability. Now become more familiar with SIPROTEC 5 and DIGSI 5. First, get a quick overview of the innovation focal points of SIPROTEC 5. Then go more in depth with the SIPROTEC 5 system details. And then get started with DIGSI 5, the innovative engineering tool for all SIPROTEC 5 devices. SIPROTEC 5, the new standard for protection, automation, and monitoring in high voltage.
Perfectly tailored fit. Individually configurable devices make tailored and cost-efficient solutions possible through the entire lifecycle. The modular system design of SIPROTEC 5 permits the perfect tailoring to your needs. System components, which are the same for all devices of the SIPROTEC 5 family, form the optimum hardware platform. Individual function packages make this hardware fit for special requirements. In this way, every user always gets the right SIPROTEC 5 device, a device which accomplishes all tasks: protection, automation, monitoring, data acquisition, protocolling, and test. A device configuration selected at the beginning of a project remains flexible throughout the entire lifecycle. If a redesign of the primary system requires more process inputs, you simply add these with expansion modules. You implement the connection to a new control station using different or additional communications modules. And if you have to accommodate a modified network, you expand the functionality of your SIPROTEC 5 device. You take care of this with the DIGSI 5 function library, conveniently and easily with drag and drop. Perfectly tailored fit. With SIPROTEC 5, that means individually configurable devices save money in initial investment, spare parts inventory, and in maintenance, as well as in the expansion and adaptation of your system. Holistic workflow. The integrated engineering makes your work easier, all the way from design to operation. To enable you to work efficiently in a shared workload environment, SIPROTEC 5 supports you holistically in all work steps. An integrated tool from system design to operation saves time and gives data integrity and transparency, even beyond department boundaries. To make the start even easier for you, DIGSI 5 comes with application templates for the most frequent applications, among others. Also for the 1.5 circuit breaker method. The multi-user concept of DIGSI 5 permits parallel engineering. You bring the individual work results together using the import interfaces. With DIGSI 5, you take care of all necessary tasks. Here are only a few examples. Creating a single line diagram, configuring the device hardware, configuring the communication structure, parameterizing test sequences for operation scenarios, Holistic workflow with SIPROTEC 5. That means an integrated tool from system design to operation, even beyond department boundaries, saves time and provides data integrity and transparency throughout the entire life cycle of your system. Designed to communicate. With the trend-setting system architecture of SIPROTEC 5, you have your communication under control. Distributed and decentralized system landscapes require intelligent grids. This is the challenge of the near future. Face this challenge with the powerful, scalable, and absolutely flexible communication of SIPROTEC 5. A change of the communication structure is not a problem for SIPROTEC 5. Regardless of whether it is a ring, star, or network, you simply adapt your device to the specific communication structure with DIGSI 5. In addition to this flexibility, SIPROTEC 5 offers you scalable redundancy for hardware and protocols. In this way, you can insert up to 4 communications modules in one SIPROTEC 5 device. The modules come in various optical and electrical designs, serial or for Ethernet, and are thus almost always compatible with the individual system configuration. Depending on the type, you can even execute 2 communications applications on one serial communications module, simultaneously and independently of one another. You could, for example, configure the first channel as the protection interface, while you communicate on the second channel using the DNP3 protocol. By the way, SIPROTEC 5 offers a large selection of protocols which you can load in a communications module. For example, also IEC 61850 in the editions 1 and 2. You conveniently select the appropriate protocol with DIGSI 5. Designed to communicate. With SIPROTEC 5, that means communication as a central component of the system architecture provides you with the necessary freedom and security that you require for a highly networked system landscape, today and in the future. IEC 61850, simply usable. Regardless of whether you mainly proceed in an application-oriented manner or prefer to think in standard structures, SIPROTEC 5 makes the complete potential of the IEC 61850 world standard simply usable. As an application specialist, you do not come into contact with the complexity of IEC 61850 because DIGSI 5 converts the standard structure into your familiar view. Let's take the single-line configuration as an example. In IEC 61850, the system specification description describes the primary topology of the system. Each device is described through an IED capability description. With the single-line editor, you establish the standardized link between SSD and ICD by assigning primary objects in the bay to functions in the devices, as easily as in a drawing program. Just as easily, you proceed with the configuration of the Ethernet network structure. Simply draw a line between 2 SIPROTEC 5 devices and DIGSI 5 immediately knows that these 2 devices are to communicate with each other in an IEC 61850 subnet. With that, you also lay the foundation for the goose communication, that is, for the direct data exchange between the SIPROTEC 5 devices in the individual bays. When, for example, you create an automation function for the SIPROTEC 5 device in Bay 1, you can directly use the signals of the neighboring bay devices as input or output information. With the help of the signal catalog and using drag and drop, you take care of this in just a few seconds. DIGSI 5 then automatically creates the necessary goose information. In this way, you implement bay crossing automation quite easily without having to worry about the goose communication. As an IEC 61850 expert, you can adopt the Goose communication at any time with DIGSI 5, and you can even create your own Goose applications and links. But not only that, with DIGSI 5, you optimize the IEC 61850 structure exactly to your requirements. You supplement the structure, for example, with additional elements such as logical devices or logical nodes. You can also shift logical nodes within the structure. And you add user-defined signals which you quite easily drag from a library and place at the desired location in the structure. By the way, with individual names, you adapt the IEC 61850 structure optimally to your company-specific terminology. With that, you lay the foundation for highest interoperability and cost-efficient operating concepts. IEC 61850, simply usable. With SIPROTEC 5, that means the implementation of IEC 61850 equally supports the working methods of application specialists and IEC 61850 experts. Your operational needs are optimally supported and handling is significantly simplified. Smart automation for transmission grids. SIPROTEC 5 offers a unique spectrum of integrated functionalities for all requirements in a modern, intelligent transmission network. With SIPROTEC 5, you have the optimum automation platform for your high-voltage grids. Regardless of how the structure of a grid changes, SIPROTEC 5 supports you with the automation and, as an essential real-time component, always ensures the stability of the network. You create the necessary automation functions with the optimized function blocks, which are based on the IEC 61131-3 standard. DIGSI 5 consolidates these blocks in libraries and makes the creation of additional functionalities a walk in the park. Further intelligent functions, such as the phasor measurement, make the high-precision acquisition and processing of process quantities possible. Over Ethernet and in conjunction with IEC 61850, you transmit the obtained data effortlessly to other devices in the grid. Smart automation for transmission grids. With SIPROTEC 5, that means devices especially developed for the requirements in the high-voltage grid supply the necessary platform for protection, automation, and monitoring, and thus offer long-term investment security. Safety and security inside. Multi-layered protection mechanisms give you maximum safety and availability. The safety concept begins with the SIPROTEC 5 device itself. The rugged hardware and an ingenious layout of the entire electronics ensure highest stability with regards to voltage, EMC, climate, and mechanical load. Sophisticated self-monitoring routines reliably localize device faults and indicate these promptly, for example, to DIGSI 5. An encryption along the entire communication line between DIGSI 5 and the SIPROTEC 5 device provides the required data security. But the encryption is only one part of a multi-level safety chain. A connection password, according to NERC SIP and BDEW white paper, protects the remote access to the SIPROTEC 5 device. The device itself records each access attempt in a non-volatile safety log. And safety-critical operations at the device and the system require the input of confirmation codes. Safety and security inside. With SIPROTEC 5, that means through the multi-layered protection mechanisms, your plants and systems are equipped with maximum security and reliability. With SIPROTEC 5, you absolutely fulfill the newest requirements of international standards and technologies.
Perfectly tailored fit. With SIPROTEC 5, you decide what you want and what you don't. Siemens then supplies you with your individual SIPROTEC 5 device, completely assembled and perfectly tailored to your needs. The SIPROTEC 5 modular system, with its various combinable components, makes it possible. These components are base modules and expansion modules, each with different input and output boards, different operation panels, for example with large display or with key switch, and a multitude of plug-in modules for communication, measured data acquisition, and memory expansion. The simple equation applies: one base module plus optional expansion modules, each with the appropriate operation panels, plus the required plug-in modules equals the hardware for your individual SIPROTEC 5 device.
Good, then let's get started. To protect a line, I need a device with at least 4 voltage and current inputs, but it could also become more.
Got it. Here's our suggestion. First, you take a base module, for example with the input-output module I0202. Included with this module, you get 4 analog voltage inputs, 4 analog current inputs, 11 binary inputs, 9 binary outputs. You can increase the number of inputs and outputs at any time with expansion modules. But first, let's take a closer look at the process connections. For these connections, we now use plug-in terminals. A definite advantage for you because you can pull off the terminal blocks and easily pre-wire them in the rack. You then plug the terminal blocks on the SIPROTEC 5 device and secure it with only 4 screws. That's it. The positive side effect of this intelligent assembly solution: wiring errors are practically impossible when you exchange a device. The current terminals themselves are a further innovation because the transducers for the 4 currents are now integrated directly in the terminals. With these current terminals, you first of all save time when you exchange a SIPROTEC 5 device because you no longer have to interrupt the connection between the device's current transducers and the primary current transducers. But more than that, you get considerably more safety because open secondary circuits are now a thing of the past. And that is only one example of safety and security inside. Let's come back to your requirement. If you need more process interfaces, add expansion modules to the base module, even anytime in the future. We guarantee you that the assembly is easy because the individual modules can be securely connected to one another in no time. Plug in, press on, finished. A bus connection automatically establishes the data connection between the modules. You don't need any extra cable for that. This way, you can get a 19-inch wide device at maximum expansion.
Freely configurable, expandable at any time. That's really a perfectly tailored fit.
Yes, but the separate housing units, of course, also provide a series of further brownie points when compared to large housings with racks. On the one hand, you save room because a SIPROTEC 5 device only occupies the space that is actually functionally needed. On the other hand, you don't need to open the housing at any time because you don't have to install any modules, you only add expansion modules. But that is not all. An ingenious thermal concept reduces the development of heat in the individual modules and discharges what little residual warmth there is over integrated heat sinks. The benefit: the housing doesn't require any openings but is completely closed. This ensures that no dust gets inside the SIPROTEC 5 device. A high electromagnetic compatibility. And, in summation, an optimum availability and a long lifetime.
Well then, a real brownie point for safety. For me though, it should begin with a clear and logical operation directly on the device.
No problem. With various operation panels, SIPROTEC 5 is here also sure to fulfill your requirements. For base modules, you have the following versions. With LEDs. With LEDs, keypad, and standard display. With LEDs, keypad, and large display. For expansion modules, you can select from the following versions. Without operator elements or control elements. With LEDs. With LEDs and key switch. With these different versions, SIPROTEC 5 surely has the right fit for all applications. Up until now, you've seen the built-in unit. But you can also order every SIPROTEC 5 device, regardless of the individual configuration, as an assembly device. Assembly devices are designed for assembly on a flat wall area. They have a cover plate and 2 cross rails. You screw these cross rails on the wall area. All connections are thereby directed to the front. For the version with the integrated operational panel, shims create a gap between device and operation panel. This area serves as a wiring space for the cable connections. For the version with separated operation panel, you can mount the operation panel locally independent of the SIPROTEC 5 device. A data cable then creates the connection between both components.
Then nothing more can go wrong. What do you think?
Well, first of all, I would like to take a closer look at the operation. You have already addressed the different operation panels. I would like to know more about them. For us, a clear operating concept which permits smooth plant management is what is important. Either by software from a distance, but of course also directly on site.
To be better able to explain the on-site operating concept, let's take a closer look at the operation panel with a large display. With this version, a high-resolution display provides enough space for information. This information can be shown in a multitude of languages. Underneath the display is a 12-part keypad. In combination with 4 navigation keys and 2 context-related keys, you have everything to easily and quickly navigate through all information in the display. By the way, you can assign each key of the keypad an individual function, which you then call directly. This provides additional security in critical situations because you can, for example, jump specifically to a particular submenu. 2 LEDs at the upper section of the operation panel give you information about the current device status. 16 further LEDs to the left next to the display ensure a fast and targeted process feedback. You yourself define which information is assigned to each of these 16 LEDs. The control key and the 2 off and on keys form the control block. With the control key, you display the control screen in the display. With the 2 off and on keys, you can then control primary equipment, which you have highlighted in the control screen. A reset key for the LEDs makes the operation panel complete. That's how easy and clear operating can be. You operate, configure, and parameterize your SIPROTEC 5 device even easier with DIGSI 5, the innovative operating and engineering software for all SIPROTEC 5 devices. With DIGSI 5, you take care of all necessary tasks. You query process data, evaluate fault records, or control primary equipment, all that and much more. For example, directly from your desk.
That's handy. What about the modularity of DIGSI 5? Does perfectly tailored fit apply here as well?
Of course, you can utilize DIGSI 5 just like SIPROTEC 5 according to need and thus have flexibility in costs. Simply decide on the variant that best fits your requirements. For simple applications, select DIGSI 5 Compact. With this variant, you already take care of most standard tasks, such as setting parameters, but also reading out process data. The DIGSI 5 Standard variant has considerably more functionality. This includes, among other things, the now fully integrated function chart editor for creating sophisticated special functions, and the expanded display editor with which you can now also create your own symbols. But there is more. With DIGSI 5, you reproduce the topology of a system as a one-phase representation. You configure SIPROTEC 5 devices and communication networks graphically. In doing so, you benefit seamlessly from the advantages of the IEC 61850 standard in the editions 1 and 2. You want more? Then go for the premium variant and experience how DIGSI 5 unfolds its full potential. With this high-end variant, you test devices and functions with the integrated test suite. You evaluate fault records with a professional analysis program, SIGRA. And you make use of the benefits of flexible engineering for IEC 61850. Regardless of which variant you decide on, the operation of DIGSI 5 is more user-friendly than ever. Browsing through individual dialogues is passé. Instead, all elements such as project tree, editors, libraries, and properties windows are seamlessly integrated in one common user interface. At any time, you can easily adjust the user interface to your working method, a feature that quickly pays off in daily use. That way, you always have everything you need within reach, even your SIPROTEC 5 devices. Because with DIGSI 5, you operate them from a distance, just as if you were right next to them.
Fantastic! With that, we have our SIPROTEC 5 devices completely under control, even in the operation.
With the optimum communication, that shouldn't be a problem. Right up front, I have a question. My notebook no longer has an RS-232 interface. It only has a USB. Is that a problem if I'm on site and I have to read out data from a SIPROTEC 5 device, for example?
No, quite the opposite. For fast data exchange directly with the device, use the USB operating interface on the base module. It's easily accessible from the front and well protected by a plastic cover. With that, you're bound to find connection to every modern notebook, and all that completely without network configuration. But that's not all there is about the USB. With the second USB interface, every SIPROTEC 5 device is prepared for the connection to a USB stick. With this, you can read out and store indications, fault records, and diagnostic data from the device. Then you transfer the data to your PC to evaluate it there and also to archive it. By the way, you can also work in the reverse direction and download the entire device settings into the SIPROTEC 5 device using a USB stick. But USB is only one of many communications possibilities, for Designed to Communicate is one of the innovation focal points of SIPROTEC 5. For that reason, every base module has a permanently integrated Ethernet interface. Through this, you comfortably operate your SIPROTEC 5 device from a distance. If you use a switch, you can even communicate with several SIPROTEC 5 devices simultaneously using one and the same PC, for example, even through your notebook, which you connect with the existing network. Through the Ethernet interface, you will also be able to connect further input and output devices in future. Each base module has 2 slots in which you can also insert communications modules. This ensures the necessary flexibility for the system communication because the installation of these modules only requires very little effort.
Let's assume that I need more than the 2 already existing communications modules for my network. What do I do then?
If 2 slots are not enough for your requirements, simply add a CB202 expansion module to the base module. The CB202 expansion module has slots for 2 further communications modules. With that, you have, with the modules, up to 8 communications interfaces available in total. The CB202 has its own power supply. That way, you are completely independent of the base module with regards to power and increase the availability of your communication structure. Here's an example. You have integrated your SIPROTEC 5 device through the CB202 into an Ethernet ring topology. When you have planned maintenance work, power is switched off to the entire device, including the base module. Because of the separately powered CB202 module, the ring remains connected and communication continues uninterrupted. But back to the communications modules themselves. The SIPROTEC 5 modular system includes modules for serial or Ethernet-based communication. The communications modules come in various optical and electrical versions and thus almost always compatible to the current system configuration. The modules' connections are even completely compatible to the cabling of SIPROTEC 4 devices. Let's just go into a little bit of detail. Depending on the type, you can execute up to 2 communication applications on one serial communications module in parallel and independent of one another. For example, you can use the same serial protocol twice on one module and send the information to a station host system on 2 independent transmission paths. In this way, you readily implement redundant structures even in conjunction with serial protocols. Or you use one of the 2 channels as a standalone active interface and thus implement a synchronous serial point-to-point connection between any SIPROTEC 5 device types. You use this type of connection, for example, for differential protection. Depending on your requirements, you can design the communication structure as a chain or as a ring. If a data connection fails within a ring structure, the communication automatically continues through a chain. Your differential protection remains completely functional in spite of a connection failure. Now let's take a closer look at the communications modules for the Ethernet-based communication. One thing is the same for all versions. The physical interfaces all exist twice. With this feature, redundant structures can easily be built up in conjunction with external switches because only one of the 2 interfaces is active at any time. If the active interface fails, the module automatically switches within milliseconds to the interface that has been inactive and now executes all applications through this interface. In addition, each Ethernet module has an integrated switch. You can alternatively use the 2 interfaces to pass on signals. In this way, you easily implement a ring topology and, by connecting the SIPROTEC 5 devices with one another, save the cost of external switches.
Impressive, but does such a broad functionality not have a negative impact on the actual protection performance?
No, absolutely not. Each module, regardless of whether serial or Ethernet-based, has its own processor with its own firmware. That way, the communication applications can run separately from the rest of the applications, such as protection or control. That not only means significantly higher security, but also maximum performance for all applications.
High security and maximum performance. I'm curious if that's also valid for measured value processing. Of course, we have to optimally protect our equipment. But at the same time, we want to carry out extremely exact measurements. Can that all be done with SIPROTEC 5?
Extremely exact measurement and at the same time being on the safe side, with SIPROTEC 5 that can even be done with cost savings in one single device. All you have to do is select the transducers for the current inputs that are appropriate for your planned applications. That is, either protective input transducers or measuring input transducers. As soon as you plug on the current terminals, the SIPROTEC 5 device recognizes the integrated transducer type. You don't have to do anything else. That way, you always have the optimum dynamic area available for every input signal. This benefit can not only be used for the base module, it also applies to all expansion modules. When the signal arrives at the input of the SIPROTEC 5 device, 24 bits ensure sufficient exactness for the analog-digital conversion. The high sampling frequency of 16 kHz allows for signal processing over a wide frequency operating range. To optimally utilize the resources of the entire system, the pending data amounts are always adjusted to your application through the use of resampling procedures.
In many cases, the generator frequency deviates from its rated value. Does this lead to a corruption of the measuring results?
Not with SIPROTEC 5. You get a handle on deviations from the rated frequency with a sampling frequency tracking, a powerful adaptive algorithm. This procedure continuously adjusts the sampling frequency to the current frequency and also provides a constantly high measuring accuracy for deviations in the range of 10 to 80 Hz.
With this flexibility and exactness, the requirement for monitoring network stability and network quality is practically made, isn't it?
That is correct. An example for the monitoring of network stability is the pointer calculation integrated in all SIPROTEC 5 devices. Synchronized with the extremely exact second pulse, the SIPROTEC 5 devices simultaneously record pointer sizes and the power frequency. GPS makes it possible. Using a fast Ethernet connection, a data concentrator collects the information of all devices. The data concentrator passes on the collected information to central evaluation systems or network control systems. The integrated pointer calculation is only one of many intelligent functions, by the way, with which SIPROTEC 5 supports the smart automation for transmission grids.
With that, we are best prepared for challenges that result from distributed energy supplies. What do you think?
I concur completely. But how can we now functionally convert our specific application?
Regardless of which equipment or which system part you want to protect, before you begin configuring, you will always have your concrete application in mind. With the new application-oriented function concept from SIPROTEC 5, we make your point of view a principle.
That sounds good. But where's my benefit?
You save considerable time and win additional flexibility. Because right at the start of configuration, you only have to select a so-called application template in DIGSI 5, for example, for line protection. With that, you already have defined the complete functional scope of the SIPROTEC 5 device for this application. In many cases, you can adopt the selected application template as is. As well, you also have the opportunity to optimize the functional scope of the application exactly to your individual needs. For perfectly tailored fit, it is also true for the functional aspects of SIPROTEC 5. A SIPROTEC 5 application encompasses all functions of a SIPROTEC 5 device. Function groups structure the individual functions according to logical aspects. A function group usually mirrors a part of the primary system, for example, a line or a circuit breaker. An application not only defines the scope of the functions, an application only becomes complete through logical measuring points and connections. Logical measuring points serve as interfaces to the process and pass on the current and voltage values that the transducers supply to the function groups. For this, every function group has interfaces for incoming and outgoing information. That way, the measured values are available to every function within a function group, and even the function groups can communicate with one another this way. The best part is, you can configure measuring points and connections. A fixed wiring between inputs, outputs, and functions is finally a thing of the past.
Brilliant! What other possibilities do I have to modify an application?
Quite a lot. In the following, we will show you a few. If your application necessitates it, you add predefined function groups to it. You can even create one and the same function group several times within an application and thus save a lot of money that way. For you can now protect various equipment which up until now had to be protected with one device each, with only one SIPROTEC 5 device. But even a function group is in no way a rigid structure. You can copy functions, for example, within a function group. That even works between two function groups. In this case, you can even shift functions. And you can add further functions. SIPROTEC 5 provides you with a multitude of modular functions for this. And from this collection, you select the ones that you require additionally for your application. For many functions, you can even define how many stages they should have. That way, you adapt functions exactly to individual protection concepts. The great thing about this is, in SIPROTEC 5, the same functions are built up identically in all device types. The overcurrent protection function, for example, works exactly the same in a distance protection as it does in a transformer protection.
So does that mean understand it once and immediately use it in all devices?
Yes, or put another way, less time for training, a lower error quota, and at the same time higher flexibility while configuring. Because you can even copy completely parameterized functions between any SIPROTEC 5 devices.
Really effective. But all that surely has its price.
You determine the price because, with the type of engineering you've been shown, you can really save money.
And how does that work in detail?
Quite simple. With SIPROTEC 5, you no longer buy a rigid function package, but so-called function points. For with SIPROTEC 5, functions have a specific value expressed in function points. An example, let's assume you require 4 function points to configure a function A. For function B, you require, on the other hand, 8 points. In total, your point credit must have 12 points. But you can also configure a function C, which has a value of exactly 12 points. To refill your point credit, you simply order the required function points through the Siemens ordering portal. That way, you always only pay for what you actually need.
Very good. I think we now have all the information we need to configure our first SIPROTEC 5 device.
I'm impressed by the modularity of the new SIPROTEC 5 system. I wonder how the configuring and ordering works.
Absolutely easy. The holistic workflow of SIPROTEC 5 includes the device configuration. The SIPROTEC 5 configurator supports you in this. With the SIPROTEC 5 configurator, you put together your personal device almost any way you like, and that even quite easily via the internet. The hardware, the application area, and some additional features together result in the product code of the SIPROTEC 5 device. With this product code, you then order your personal SIPROTEC 5 device. But one thing after the other. The configurator's start page offers various possibilities to get to the product you desire. In the first place, you use the SIPROTEC 5 configurator to completely configure your individual SIPROTEC 5 device and everything that goes along with it. Alternatively, you enter an already known product code. This way, you can configure a further SIPROTEC 5 device on the basis of the device configuration that belongs to this code by making a few modifications. But even in the selection of individual components, when deciding on the appropriate DIGSI 5 variant, or when putting together a function package, the SIPROTEC 5 configurator gives you the necessary help.
That really sounds quite easy and plausible. But could we still design a sample configuration together?
Gladly. To configure a SIPROTEC 5 device according to your visions, follow the appropriate link in the configurator. That way you get to the actual configuration process. The SIPROTEC 5 configurator now leads you step by step to your goal and always only offers you the options to the selection that you actually really need. With a selection of a standard version, you decide for a predefined configuration that facilitates your individual configuration. You can adjust the selected standard variant to your requirements as you go along. And then you determine how many function points you want to order for your SIPROTEC 5 device.
Quick question. How do I know how many points I need?
A point calculator supports you in the selection of the applicable point class. All functions that are available in the selected SIPROTEC 5 device are listed in this point calculator. Simply select an application template and you can already see which functions you require for it. You can now select additional functions or deselect highlighted functions. The point calculator immediately calculates the necessary function points. In the further steps, you specify the modules, the communication features, and the housing design. Regardless in which configuration phase you currently find yourself, the configurator always gives you practical help. So you can, for example, display the terminal assignment of a selected expansion module. If you would like to look at the result of your configuration, a mouse click is enough, and the SIPROTEC 5 configurator lists all of the details. One more click and you even get the result as a PDF file, including the complete product code of your SIPROTEC 5 device. With this product code, you can now order the SIPROTEC 5 device in the Siemens ordering system. And while your personal SIPROTEC 5 device is being delivered, your colleague can use the product code from the PDF file as the basis for the configuration in DIGSI 5.
Really a true holistic workflow.
Your entry in DIGSI 5 is really easy. You install DIGSI 5 onto your Office PC in addition to your other applications and immediately seamlessly implement all your requirements. You only have to ask yourself one question.
With what do I want to start?
DIGSI-5 offers you a never-seen-before holistic workflow. This holistic approach to integrated engineering from the first mouse click to the operation of the system facilitates your work right down the whole line. An example: you would like to insert an already bought SIPROTEC 5 device in a DIGSI-5 project as quickly as possible without having to worry about the topology of the system? Then just do it in only 2 steps. Step 1. Enter the product code that is imprinted on your SIPROTEC 5 device. Step 2. Select the appropriate application template in order to define the functional scope for the SIPROTEC 5 device. That is all you have to do in DIGSI-5 to be ready for takeoff. By the way, DIGSI-5 offers you a wide range of application templates, so you can even implement complex applications such as the 1.5 circuit breaker application with a flick of the wrist. Or you would rather use the system topology. No problem. For this, you can, for example, import topology data in the LCAD or SSD format into the DIGSI-5 project. The single-line configuration then shows you the system topology in the view you are familiar with. With a single-line editor, you can change the imported topology at any time, or create a completely new topology. For this, all necessary symbols, such as bus bars, circuit breakers, or transducers, are available for you in a library. This library even offers you complete templates, which you can use for the single-line configuration. With them, you always reach your goal, quickly, easily, and intuitively. For with DIGSI-5, you concentrate on your work and not on the tool. This flexible working method continues consistently with the configuration of the exactly required function range. This way you add individual functions and complete function groups easily and right to the point with the help of the library. This not only works in the single-line editor, but also within the information matrix, or directly in the tree structure of the project tree.
Fantastic! Do you set up a function just as flexibly?
Yes. In the project tree, you simply double-click on the function name. And DIGSI-5 presents all settings of the function as well as the associated values. However, if you are momentarily working with the information matrix, for example, you don't have to close it, because the function structure of the project tree is mirrored in the information matrix. Through the Properties window, you also have easy access to the function settings from here. With the information matrix, you route indications, measured values, metered values, and commands. In the simplest case, to inputs and outputs, but also to LEDs, to function keys, or to the event protocol buffer. Quickly and intuitively, you link certain information with a source and a target via the context menu. In the process, you can also recognize how the modularity of the hardware is reflected one-to-one in DIGSI-5.
Oh yes, that's right. In SIPROTEC 5, a device is made up of individual modules, isn't it?
Right. The modular hardware concept of SIPROTEC 5 also gives you the leeway to change a SIPROTEC 5 device as needed. And DIGSI-5 gives you its full support. With the help of a catalog, you add, amongst other things, communications modules, select suitable current terminals, or expand the memory of the SIPROTEC 5 device. Everything according to your need, everything by drag and drop, everything very easily. Now, quite honestly, where else can you find this convenience?
Admittedly, I have to pass. But what are my choices for creating additional functions, for example, for automation?
That's also been taken care of. With optimized function blocks based on the IEC 61131-3 standard, you configure your own functions, for example, for measured value processing or for control tasks. With that, you create integrated automation solutions for your high-voltage grid without additional costs. The key to your own functions is the function chart editor. With this, you create complete functions from the individual function blocks, from simple to complex. You simply drag the function blocks from the library onto the function chart, also called a CFC. After that, you connect the blocks with one another and then link these with input and output information. All information of the information matrix is now constantly available for selection. You don't have to root it first. And another highlight, the tracing helps you to test a function before you load it into a SIPROTEC 5 device. With this, you definitely move onto a new level of engineering. By the way, you take care of all engineering tasks offline on your PC without requiring a SIPROTEC 5 device for this. You can even divide the entire task amongst several persons. That saves time and makes efficient working possible. If you need data from other sources during configuration, you can integrate it in your project with XML using an open exchange format. You later transfer all data online in the SIPROTEC 5 device, for example, directly through the USB interface in the operation panel. Alternatively, you transfer the data via the Ethernet network. The communication structures required for this you also configure graphically. Simply draw a line between two SIPROTEC 5 devices and DIGSI 5 immediately knows that these two devices are to communicate with one another in a subnet. It couldn't be easier.
I'm impressed. This is really
perfect. The best thing is to now look a little bit closer at the system integration.
Designed to communicate. Due to the trend-setting system architecture of SIPROTEC 5, communication can also be adapted. This is important because a powerful, flexible, and more importantly, reliable communication is the prerequisite for distributed and decentralized system landscapes.
It all sounds very good, but what does that mean in real life if I would like to, for example, use a different communication protocol?
Then you configure the communications module of your SIPROTEC 5 device to fit your requirements, and quite conveniently with DIGSI 5. In SIPROTEC 5, a communications module is not bound to a particular protocol. Instead, you have a series of protocols to select from. Here is an overview of what SIPROTEC 5 offers you to get your data from A to B. Of course, SIPROTEC 5 supports the latest IEC 61850 standard, not only fully compatible to Edition 1, but also in the current Edition 2. SIPROTEC 5 still offers you full support of the serial protocol IEC 6870-5-103. That way, you stay fully compatible to existing system structures. Secure DNP3 for both serial and Ethernet-based data transmission is also on board, just as the protocol for the synchrophaser procedure. This variety shows that communication is a central component of the system architecture of SIPROTEC 5. Besides traditional serial data transmission, SIPROTEC 5 mainly uses communication via Ethernet in conjunction with IEC 61850. SIPROTEC 5 makes the entire potential of this world standard easy to use for you. That is why one of the innovation focal points of SIPROTEC 5 is called IEC 61850 Simply Usable. We would like to show you, on the basis of a simple system structure, why that is so. The integrated Ethernet interface is already enough to integrate the SIPROTEC 5 device in a system as a simple IEC 61850 server. A server configured this way can provide one single client with data. The client in this case is a SICAM PAS. With this, you get a functional, fully fledged alternative to IEC 6870-5-103, and that without further expense. To integrate the SIPROTEC 5 devices in an IEC 61850 system as a high-speed server, you use one of the Ethernet-based communications modules. With the help of the module, the SIPROTEC 5 device can pass its data to up to 6 clients. And it can communicate horizontally with other devices with the Goose service of IEC 61850 with transmission times from transmitter to receiver of less than 5 milliseconds.
Since we're just talking about time, what are the possibilities of time synchronization?
With SIPROTEC 5, you have many options for providing for a uniform time base in the system, for example, with the internal time synchronization for the simplest system structures. For networks, you can integrate 2 redundant time sources using SNTP. When one time source fails, the second time source automatically takes over the time synchronization. But even directly on the device, port G offers you many possibilities. For example, you can connect a GPS receiver to this port. It supplies an extremely exact 1-second pulse that has an exactness of 1 microsecond. With that, you fulfill the prerequisites for the use of the SIPROTEC 5 device as a phasor measurement unit. For every SIPROTEC 5 device, you can, by the way, select 2 independent time sources. You easily set all options for time synchronization with DIGSI 5. With Ethernet, you can also integrate the DIGSI PC in any location in the system. In that way, you can immediately operate and monitor all SIPROTEC 5 devices connected to the network in parallel with only one DIGSI 5. Of course, you can also integrate SIPROTEC 4 devices and SIPROTEC compact devices in the shown communication structure directly over Ethernet interfaces.
Naturally, we protect our network structure with the known safety measures such as firewall, network segmentation, and gateways. What security can SIPROTEC 5 offer us?
One of the innovation focal points of SIPROTEC 5 is safety and security inside. Many layered security mechanisms on several levels offer the protection for your SIPROTEC 5 device that you require for a highly networked system landscape. With regard to data security, SIPROTEC 5 delivers its contribution through an encrypted point-to-point communication between DIGSI 5 and a SIPROTEC 5 device. This encryption permits a secure, worldwide remote service even over unsecured networks. But the encryption is only one part of a multi-level security chain. First of all, the user must enable the remote access to the SIPROTEC 5 device with a password. The password conforms to the strict regulations according to NERC-CIP and BDEW white paper. As soon as a connection is established, DIGSI 5 must authenticate itself because you can only exchange data with a SIPROTEC 5 device with DIGSI 5. Access via another software is not possible. After successful authentication, the SIPROTEC 5 device enters the IP address of the accessing PC together with other data in the so-called security history log. User profiles regulate the actual leeway for action. Only authorized users can carry out safety-critical operations, for example, the switching of primary equipment. You can additionally secure such safety-critical operations through further passwords. As you can see, sufficient security in communication, and with that in the operation of a system, is taken care of.
Operation, that is your topic.
Before we commission system parts, we must be sure that everything's okay. That's why powerful test functions are indispensable.
In DIGSI 5, you have a multitude of test and operator control functions. These are clearly organized within the integrated test suite. A double click is enough to parameterize and activate the respective test function. Quickly and without problems, you check binary inputs, binary outputs, and LEDs of a SIPROTEC 5 device. Or you test protocols and thus tracked the effect of an indication sent over the system interface. Just as easily, you test circuit breakers with different test procedures. An absolute innovation, however, is the simulation of signal sequences by using test sequences. Up until now, to test the effect of functions in the device, you had to work with signals from external test equipment.
This test equipment isn't exactly cheap.
Right, but as of now, you can considerably reduce such additional costs because instead of the external test equipment, you simply use your notebook together with DIGSI 5. And instead of extensive cabling, you only need an Ethernet cable.
And how does that work in detail?
Every SIPROTEC 5 device has integrated test equipment. This test equipment plays back a so-called test sequence in real time and stimulates the SIPROTEC 5 device's functions just as a real signal sequence at binary and analog inputs. So that this works, the process signals are not taken into account during the simulation. For this, the integrated test equipment interrupts the internal connections between the process inputs and the logical measuring points. Instead of the process values, the test equipment now routes the values of the test sequence directly to the logical measuring points. These pass on the values, dependent on the respective application, to the functions.
Ingenious! And I can create such test sequences with DIGSI 5?
Yes, the creation of test sequences is just as seamlessly integrated in DIGSI 5 as all other tasks. A test sequence consists of at least one test step that ends after a parameterizable time. Within a test step, you define for different analog values whether they are to be constant, increase, or fall. Even binary inputs can be activated or deactivated with a test step. You can combine up to 6 steps into one test sequence and thus generate individual signal sequences. In this way, you very easily create a supply of different test sequences with DIGSI 5. You then transfer these into the SIPROTEC 5 device and activate them there as required.
Good. Well then, we've successfully tested and can commission the system. How do we handle the large amount of process data?
Simply rely on the extensive event logging of SIPROTEC 5, which stores all measured values and signals from the process for you. All SIPROTEC 5 devices have a multitude of event protocol logs with considerably increased storage capacity. Of course, SIPROTEC 5 offers the usual logs, for example, ground fault logs, operational logs, and fault logs. Newly added are, among others, the already described security history log and the history log for the settings history. This log records changes to parameters and configuration data. As well, you can now configure your own logs. You decide about the information types to be recorded, the length, and the reason. Perfect to configure a separate fault log for a second protective object, for example. By the way, you very easily read out the log contents with DIGSI 5.
In spite of all measures, system incidents do occasionally occur. For example, a ground fault due to an open phase.
In such cases, the powerful fault recording of SIPROTEC 5 will help you. The variable sampling frequency and a large memory make a powerful fault recording possible, and that with up to 40 analog channels plus additionally calculated measurements. The system is set up in such a way that with a sampling frequency of 8 kHz, the maximum recording time is 20 seconds. This version is recommended, for example, for the analysis of harmonics. For the analysis of protective triggers, sampling frequencies of 1 kHz are more than enough. In this case, the recording time increases to a fantastic 160 seconds. The number of records is only limited to the maximum recording time. To read out the records from the affected SIPROTEC 5 device, you don't have to be on site, of course. Through an Ethernet connection, you also take care of this from a distance, reliably and without effort. In that way, you can evaluate the fault records at any time and anywhere, for example with SIGRA, probably the world's best fault record analysis program. If you have installed DIGSI 5 in the premium version, a double click on the fault record name is enough, and SIGRA already displays the fault record data. The representation as bar chart, as time signals, as vector diagram, or as circle diagram, for SIGRA none of that is a problem. By the way, SIGRA can also be bought as standalone and as an option package. With the following topics, we will give you a quick introduction to practice-oriented working with your new DIGSI 5. As the basis for our practical task, we have selected a single busbar configuration. This configuration can frequently be found in industrial production facilities. A coupling divides the busbar into two sections. On both sides of the coupling, there are several outgoing transformer lines. Each busbar section has its own feeder. In the normal operating state, the coupling is open. Each busbar section and the outgoing lines connected to it are supplied with energy through their own feeder. Imagine the following scenario. Due to a mains failure, the energy supply through feeder 1 is interrupted. As a result, busbar section 1 is without energy. So that this section is once again supplied with energy, feeder 2 is to automatically take over the supply of power. For this, the circuit breaker in feeder 1 must first of all be opened. Then the coupling must close so that feeder 2 can take over supplying the outgoing lines on busbar section 1 with power. By the way, the outgoing transformer lines are not relevant for our task. For that reason, we won't take these outgoing lines further into consideration. The two feeders and the coupling each have their own SIPROTEC 5 device assigned to them. An automatic switchover will provide the described response to the loss of energy. We will implement this automatic switchover with the help of CFC functions in device feeder 1. The automatic switchover detects the loss of energy, opens circuit breaker 1, and generates an indication in device coupling via cross communication. Device coupling then sends a close command to the circuit breaker of the coupling. If the cause of the loss of energy was a fault on the bus bar, the function must not release the switchover. The automatic switchover must block such an event. In addition, the user must be able to deactivate the automatic switchover with function key 2. This is necessary, for example, before circuit breaker 1 is knowingly opened through a control command. The automatic switchover can be reactivated with function key 1. Later on this DVD, we will show you what is essential for solving our task. In some areas, we will explain the procedures simply. In other areas, we will give you additional information that is not necessary for the example. Before we begin to solve our task, we would like to present the new operating concept of DIGSI-5. DIGSI-5 manages parts of a system and all of the data associated with it in a project-oriented manner. Topology, devices, parameters, communication settings, process data, and much more are compiled and stored under one project name. This means that all you have to do is open a project file and you will immediately have all data available. Vice versa, you save all modifications, regardless of the type, with only one mouse click. The project tree is the central element when working with DIGSI-5. Through the project tree, you have access to all data and tools. In each case, a double click is enough and you display setting values of protection functions, start actions such as the transmission of device data, or open one of the editors in order to edit a function chart, for example. DIGSI-5 displays all editing tools within the working area. Included in these editing tools are, for example, the single line editor, the information matrix, or the display editor. Through buttons, you can easily switch between the open tools with a mouse click. On the right side, you see the task area. In this area, you find context-related tasks or functions, but that's not all. The global DIGSI-5 library plays a particular role. It contains a multitude of elements which you can insert in the project using drag and drop. If you are interested in a particular element, the inspector window can help you out. It immediately supplies you with the appropriate display and input possibilities depending on the selected element. You don't have to open any additional dialogues. As you can see, the operation of DIGSI in the 5th generation is more effective than ever before. For optimum working, you have the flexibility to adjust the user interface of DIGSI-5. Thus, you can infinitely vary the size of the individual windows, for example. Or you completely hide windows if required. One mouse click on the arrow symbol is enough. That way, you have the working area completely in view. This is particularly useful when a lot of information has to be displayed at the same time, for example, in the Goose editor. With the split function, you divide the working area vertically or horizontally and make room for 2 editors. This lets you easily compare the settings of 2 different SIPROTEC 5 devices. Especially handy, you can even detach a window completely from the user interface and then move it freely. Let's begin with the solving of our task. The first thing to do is create a new project. In this project, DIGSI-5 will save all information about the system and the SIPROTEC 5 devices included in it. Give the project a name of your choice. In our example, we're calling the project Industrial System. Click on OK. DIGSI-5 generates and opens the project. To show the topology of our example system in DIGSI 5, double-click on Single Line Configuration in the project tree. Since you've created a new project, DIGSI 5 shows an empty worksheet for the single line configuration in the working area. To insert equipment for feeder 1, use the global DIGSI 5 library. In the folder Single Line and Display Elements, you will find the necessary elements. Begin with the first busbar section. Simply drag the required element from the library into the working area and then adjust its length. One after the other, you insert the other equipment into the configuration: the disconnector, the circuit breaker, the transducers, and so on. If you position the elements close enough together, DIGSI 5 directly connects them. You can manually change these connections at any time. As you can also see, DIGSI 5 highlights the bay in color, which automatically expands and contracts to cover the bay elements. Rename this bay Feeder 1. Now connect the busbar and the disconnector with one another. To do so, click on the upper connection point and, while keeping the mouse button pressed down, drag a line to the busbar. Then connect the other pieces of equipment in the same way as with the busbar and the disconnector. At the same time, you can reposition the icons of the equipment. Later on this DVD, you'll find out how you easily complete the remainder of the system. You set the properties of all equipment directly in conjunction with a single line configuration. We'll show you how you have to proceed using the current transducer as an example. Highlight the element for the current transducer. Then display the inspector window underneath the working area. The inspector window shows you the properties and associated values of the current transducer. With the entry fields and selection lists, you can change the values of the current transducer. If you want to specify a new SIPROTEC 5 device with an existing product code, you can start the insert procedure directly in the Single Line editor. In the Single Line and Display Elements folder, select the element SIPROTEC 5 device and drag it to the desired position in the Single Line configuration. As soon as you release the mouse button, DIGSI 5 opens the dialog Add New Device. An alternative way to this dialog is through the project tree. By double-clicking on Add New Device, you get the same result. Two entry fields accept the short or the long product code. Enter one of these two codes in the applicable entry field. Then you still have to select an application template. More on that later. First, we would like to explain another possibility for adding a SIPROTEC 5 device. In the working area, open the Network view. In this, you will now insert the basic configuration of a SIPROTEC 5 device. To do so, you use the Hardware Catalog. In the Hardware Catalog, the names of all basic configurations are arranged according to device types. When you've decided on a basic configuration, drag its name into the working area. Since you also have to select an application template when manually configuring, DIGSI 5 once again opens the dialog Add New Device. Now select an application template. With it, you determine the basic functional scope of the SIPROTEC 5 device. DIGSI 5 offers you various application templates. Select a suitable application template and then click OK. DIGSI 5 inserts the new SIPROTEC 5 device into the project. For that reason, you will find a new entry in the project tree. As well, DIGSI 5 has placed the SIPROTEC 5 device in the network view. The same is also true for the single line configuration. Here you will find the SIPROTEC 5 device as the representative for the selected application. It would be best to immediately rename the new SIPROTEC 5 device Feeder 1. It doesn't matter where in the project you do this, DIGSI 5 ensures consistency. Now let's take a look at the current hardware configuration of the SIPROTEC 5 device. You can modify this configuration anytime you like. For this, you switch to the device view. The device view shows you the back and front view of the current device configuration in a rack assembly. You can now equip the base module of the SIPROTEC 5 device with further components. To do so, drag the required components in any sequence you like from the hardware catalog onto a suitable insert position. You could, for example, begin with the current terminal and then continue with the operation panel. For the operation panel, select the version with a large display for our example. Since the devices are to communicate via Ethernet, choose an Ethernet communications module. Place this on one of the two slots. On the other slot, for example, place a transducer module with which the SIPROTEC 5 device can record analog measured values. Now add the expansion module IO207. This module expands the SIPROTEC 5 device with additional process inputs. For this expansion module, choose an operation panel with LEDs and key switch. Now the hardware of the SIPROTEC 5 device is complete. Now let's take a closer look at the selected application. So far, the application contains the function group line. We'll now add a function group of the type circuit breaker to it. To do so, you first of all have to reopen the global DIGSI 5 library. In the folder of the device type 7SL87, you'll find the appropriate element for the function group. Drag the element out of the library and onto the SIPROTEC 5 device in the single-line configuration. DIGSI 5 then inserts the new function group into the application. Now let's take a closer look at the function group line. On the left-hand side, you can see the interfaces of the function group. Through these interfaces, you can link the transducer measuring data of a feeder with a function group. To make the configuration easier to follow, you link a transducer directly with the function group interface in the single-line configuration. In reality, the transducers are connected with the analog inputs of the SIPROTEC 5 device, and these in turn with the logical measuring points. These logical measuring points are then assigned to the interfaces of the function groups. You can take care of the assignment of a logical measuring point to the interface of a function group directly in the function group. From selection lists, you choose the logical measuring points from which the interfaces are to receive the respective measured variables. If you would like to delve deeper into this topic, then open the measuring point matrix. With the measuring point routing, you can add further logical measuring points, set the connection type, and route the measuring points to the terminals of the SIPROTEC 5 device. To change the functional scope of the application, you can, for example, use the single-line configuration. Just as with the function groups, you also select additionally required functions from the library. You then simply drag these functions onto the desired function group. Through the adding of functions, the number of necessary function points increases. You check the current function point situation in the device information. The Resources tab displays the requirement of function points. Now complete the system topology. First, connect the output of the function group circuit breaker with the circuit breaker in feeder 1. Feeder 2 is to be configured identically to feeder 1. So you can copy feeder 1 complete with busbar and SIPROTEC 5 device. You only have to change the name of the bay. Now just add the coupling. For the SIPROTEC 5 device for the coupling, you can either insert it new or you can copy one of the SIPROTEC 5 devices from feeder 1 or feeder 2. Connect the circuit breaker and the associated function group, and the single-line configuration is complete. With the project tree, you get to all functions of a SIPROTEC 5 device. To display the parameters of a function in the working area, all you have to do is double-click. You can even open several functions at the same time. With a mouse click, you then easily switch between the parameters of the different functions. The parameters are clearly assigned to different function blocks. These blocks are, in the example, the stages of the function. But even the zones with distance protection or the current criteria with a process monitor are function blocks. Over the first function block, you see a selection list. With this selection list, you select the settings group whose values you want to process. With settings groups, you can save and use the respective function settings for different operating cases. All SIPROTEC 5 devices support up to 8 settings groups, which are independent of one another. You can decide how many you actually use. To do so, open the device settings directly from the setting editor and change the number of settings groups. Before you begin to set individual values, you can, if required, change the edit mode. The edit mode determines whether you must enter the values as primary values, secondary values, or percent values. Here's another tip. If you want to use the values of another settings group as the basis for your parameter assignment, you can copy these completely into another settings group with just a few mouse clicks. Alternatively, or additionally, you can also orient yourself to the values of another settings group. To do so, you first of all switch back to the function which parameters you want to set and select a comparative settings group from the selection list. DIGSI 5 displays the comparative values to the right of the values to be set. Now you can specifically change individual parameter values. Just as easy as parameter values, you change the number of function stages. With just one mouse click, you add a new stage or delete it once again. When adding stages, you can also resort back to the global DIGSI 5 library depending on the current work situation. Simply drag the stage element out of the library onto the function name in the project tree. Or use, as you already did with the additional functions, the single-line configuration as the target. Here as well, the adding of function stages works with drag and drop. Now close the editors in the working area and also the library. With the network view, you configure the communications connections between the SIPROTEC 5 devices and take care of all communication settings. That way, you fulfill the rest of the requirements for cross-communication between device feeder 1 and device coupling. The first requirement for this is already fulfilled. In each SIPROTEC 5 device, there is an Ethernet communications module. Colored squares identify the interfaces of these communications modules. To connect two interfaces with one another, drag a connection line between the interfaces while keeping the mouse button pressed down. DIGSI 5 automatically generates a new subnet and connects the interfaces over the subnet, and you have fulfilled the second requirement for cross-communication in passing. In the connecting process, DIGSI 5 takes care of the necessary uniqueness of the IP addresses within the subnet. With one mouse click, you can show the current IP addresses of the individual interfaces in the network view. If you want to set an IP address manually, you only have to highlight the relevant interface in the network view. And voila, you have access to all network-related parameters and options in the inspector window. To set other interface-related parameters, highlight the group for the channel settings. In this group, you select, among other things, the transmission protocol. For our example, it is the IEC 61850-8-1, the third and last requirement for cross-communication. As soon as you've also chosen the IEC 61850-8-1 protocol for the other two communication nodes, the signals of the other SIPROTEC 5 devices are also available for each SIPROTEC 5 device. If you require certain network protocols, such as SNTP for the communication over Ethernet, activate them with only one mouse click. After that, you have immediate access to the associated parameters. Let's briefly look back at our task. Depending on the defined requirements, device feeder 1 is to open the circuit breaker in feeder 1. Then the device is to send a signal to close the coupling on device coupling. To implement the switchover, we configure additional functions for the device feeder 1. To begin with, we'll give you a brief overview of what these functions must accomplish. Basic cause for the switchover is an energy failure on the line side. To get the necessary information about it, the voltage value on busbar section 1 is compared to a lower limiting value. Falling below this value starts a timer. This timer prevents even short voltage dips from leading to a switchover. If the voltage is still below the limiting value after the set time has run out, the timer output delivers a high signal. The continuous falling below the limiting value is the first of 3 requirements that must be fulfilled for the switchover. Second requirement, the automatic switchover must be activated. Remember, you activate or deactivate the automatic switchover with the 2 function keys F1 and F2. To query the status of the automatic switchover, we link 2 indications, ASO on and ASO off, with an SR flip-flop. A high signal at the output of the flip-flop then means that the automatic switchover is activated. The third requirement is that there is no error on the busbar. An indication which always exists when there is a trip gives you information about this. In order to be able to save this information, we link this indication with a set input of an SR flip-flop. The flip-flop is reset as soon as the trip is acknowledged. To retain a high signal when no trip exists, we have to negate the output signal of the flip-flop. Since all 3 described requirements must be fulfilled simultaneously, we link the 3 signals with an AND function. A high signal at the output of the AND function thus means an enable for the switchover. By the way, we'll distribute the procedures shown in 2 functions. The reason for this is that you have to clearly assign each CFC function to one of 4 tasks. The task decides whether a function is executed cyclically or event-triggered. Function 1 is a measured value task that is to be executed cyclically. Consequently, we assign this function to the task measurement. Function 2, on the other hand, is determined by events. The optimum task for this is called event-triggered fast. But back to our example. With the first 2 functions, we capture the current situation and, if necessary, generate from it an enable indication. The actual switchover is carried out by a 3rd function. As soon as the enable indication exists, this function gives the command to open the circuit breaker in feeder 1. After a positive response, the function generates the indication close coupling in device coupling. Every function is configured within a function chart. To add a new function chart, simply double-click on Add New Chart. In the follow-up dialog, enter a name for the function chart, for example, Voltage Monitoring. Next, select the task execution level. Since the first function is a measured value task, you have to assign the function chart to the task measurement. Check the checkbox Add and Open and click OK. DIGSI 5 opens the empty function chart in the working area. Without programming knowledge, you now create the desired function with the help of the function chart editor. In so doing, you can fall back on a wide variety of existing function blocks which are compiled, clearly structured in the library. To determine whether the bus bar is without voltage, we compare the current voltage value with a lower limiting value. For that, we need a compare block. Simply drag the compare block out of the library and place it within the chart. You can change the limiting value with which the voltage value is to be compared directly at the block's input limit. You have to interconnect the second input of the function block with the voltage measured value. For this, display the signal catalog. Make sure that the signals of device feeder 1 are visible. Then select the required measured value and drag it onto the input of the block. As soon as you let go of the mouse button, DIGSI 5 displays the interconnected signal in the form of a connector. The first function monitors whether the voltage falls below a limiting value. The second function enables the switchover dependent on the voltage falling below and two other requirements. Add a second function chart with the name Voltage Switchover. Select the task Event Triggered Fast. You first of all have to reopen the global DIGSI 5 library. From the library, drag the required blocks onto the function chart, a timer, 2 SR flip-flops, and an AND block. As you can see, the AND block only has 2 inputs by default. Since the number of inputs is a parameterizable property of the block, you can easily increase it to 3. Then set the runtime of the timer to 5 seconds. Since DIGSI 5 expects the input in milliseconds, enter the value 5000. Now connect the blocks with one another, as you've already done with the first function. After that, negate the output signal of the second flip-flop. You do this quite easily with the context menu of the connection line. You must now define and route the required indications. Use the information matrix for this. Insert the user-defined indications from the library into the desired location in the information matrix using drag and drop. We'll show you this using the indication ASO on as an example. For this indication, select the signal type single point indication SPS. As the target for this indication, choose, for example, the function trip logic within the function group circuit breaker. Now drag the signal from the library onto the function in the information matrix. You can easily change the standard name now, in our example, into the name ASO on. This way you add the other required indications. Now route the indications ASO on and ASO off to the function keys F1 or F2. You take care of this quite easily with the context menu. Simply right-click in the common cell of indication and function key and select the desired routing. And there you go, the indication is linked to the function key. Now all you have to do is define the indication close coupling in device coupling. For this, open the information matrix of this device. When you define the indication, you proceed just as you did when you defined the indications for the device feeder 1. Now link the blocks of the second function with all required indications. By the way, you will also now find the newly defined indications in the signal catalog, in our case within the function group circuit breaker in the function tripLogic. Select an indication and drag it, as already shown, onto the appropriate block connection. In this way, you also connect the other indications with the function blocks. With that, the second function is also completed. You now connect it with the first function. The actual switchover is carried out by a third function. On the output side, the function is to generate the indication close coupling in device coupling. So far, you have already fulfilled all requirements for a cross communication. For that reason, you can now quite easily link the function in device feeder 1 with the help of the signal catalog with a signal from device coupling. There is nothing else you have to do for a functioning cross communication between the two devices. You manage display pages quite easily with the project tree. All display pages that exist for a SIPROTEC 5 device are combined in one folder. To be able to edit one of these display pages, double-click on its name. DIGSI 5 opens the display page and displays it in the working area. If you would like to add a new display page, a double-click in the project tree is also enough. In this case, DIGSI 5 displays an empty display page. The new display page has, to begin with, a consecutively numbered standard name. You can, of course, change this name. You do so, for example, directly on the display page, but it is also possible in the properties of the display page or in the project tree. If you would like to use an existing page as the starting basis for a new page, then you copy this page in the project tree. This also works between the devices. By the way, the order of the display pages in the project tree defines the display sequence of the pages in the display of the SIPROTEC 5 device. With drag and drop, you can easily change the order and thus the display sequence. Let's go back to our example. To depict feeder 1 graphically on the display page, you have two possibilities. For the first way, you proceed just as you do for creating the single-line configuration. Out of the library, you drag the individual elements such as busbar or circuit breaker onto the display page. Then you connect these elements to one another. However, if you have already created a single-line configuration, then there is a convenient alternative as the second possibility. For this, switch to the single-line configuration. First, highlight the bay that is to be shown on the display page. Then click on the particular button in the symbol bar. DIGSI 5 generates a new display page that contains all elements of the highlighted bay. On this basis, you can add further elements. Dynamic fields facilitate the display of cyclically updated values in the display of the SIPROTEC 5 device. You simply place an analog or binary signal on the display page. DIGSI 5 automatically generates the required dynamic field. Then, if required, change the name of the inserted signal. With the help of the signal catalog, not only analog or binary values can be placed onto the display page. Dynamic display elements can also be linked with indications. For this, drag the indication for the position of the circuit breaker out of the signal catalog onto the circuit breaker element. Nothing more is necessary so that the display of the SIPROTEC 5 device presents the current state of the circuit breaker during running operation.
Siemens.